our analysis of Newton's Principia is going to be based on three separate things. There is, of course, the book itself, and this is available for free online. But what we're also going to do is we're going to look at the work of Subramanian Chandrasekhar, famous for his work on white dwarfs and formulating the Chandrasekhar limit. He, in his retirement, he worked through the Principia, translating the archaic language and mathematics into a modern-day mathematic analysis. So we will look in there when Newton becomes obscure, but obscure only by the ages that have occurred since this was written, originally in Latin. The third source of useful analysis is going to be this. It's going to be experimental procedure. We're going to have a little look at what experiments can demonstrate the things that Newton is talking about. So for this very first definition, what is he even talking about?
Isaac Newton's Principia Mathematica, well, otherwise known as the mathematical principles of natural philosophy. But how does it begin? What does he talk about? Well, at the very first chapter, he starts talking about the definitions that are important for all of the work that follows it. And the very first definition concerns itself with the physical quantity of mass. So here we go. The quantity of matter is the measure of the same, arising from its density and bulk conjunctly. Thus, air of double density in a double space is quadruple in quantity. In a triple space, sextuple in quantity. The same thing is to be understood of snow and fine dust or powders that are condensed by compression or liquefaction, and of all bodies that are by any causes whatever differently condensed. I have no regard in this place to a medium, if any such there is, that freely pervades the interstices between the parts of bodies. It is this quantity that I mean hereafter, everywhere, under the name of body or mass, and the same is known by the weight of each body, for it is proportional to the weight, as I have found by experiments on pendulums, very accurately made, which shall be shown hereafter.
He says the quantity of matter is the measure of the same, arising from its density and bulk conjunctly. Now this takes a little bit of thinking about, because he refers to this thing as the quantity of matter, and he is of course referring to what we today would know as mass. This is the definition of mass. It's the quantity of matter. It's how much matter an object has. And it's really curious that Newton starts this explanation first talking about matter in terms of density. Now we ourselves in the modern day would probably refer to mass in terms of Newton's second law. Force is mass times acceleration. The mass itself is a kind of reluctance to accelerate. It's the constant of proportionality between force and acceleration in Newton's own equation. But of course, we're not there yet. And as Chandrasekhar points out, these are the definitions on which he's going to build everything else, saying that mass is derivable from Newton's second law. It takes away our opportunity of deriving Newton's second law from more basic things. We make, at this point, the claim that mass is the more fundamental a thing, and we endeavour to define it in a different way. So what Newton does is he defines it relative to the formula that density is mass divided by volume. Mass divided by volume, like Archimedes in the bathtub, so basing itself on earlier work. And he makes this claim, and he talks about something, an object. He says air of double density in double space is quadruple in quantity. Now, this is where we refer to experiment here. We don't have air, but what I do have is a number of materials here. I've got some wood, and I've got some perspex. Now, these two here, they're different in density. And as it turns out, the perspex is almost exactly twice the density of the wood. Now, I could find that out through experimental procedure, but I'm going to cheat because I've got this very, very tatty science data book. It says in here that perspex has a density of 1,190 kilograms per metre cubed, and that wood, such as spruce, is about 600, so approximately half the density. Now, these two here, though different in size, would have the same mass, the same quantity of matter present as a result of their different densities. Now, Newton's words are very carefully put here, for he uses slightly different expressions. He doesn't say the word volume. He talks about its bulk. What is its bulk? And that is his word for what is this volume. And he says that the quantity of matter, the mass, is the same as, so he's putting in an equals sign here, that arising from its density and its bulk conjunctly. He's saying that the mass of this is the same as the measurement of its density and the measurement of its volume. And when he says conjunctly, he means multiplied together. But then he goes on to demonstrate this quantitatively, how these numbers might work. And he says that if I had air of double density and double the space, it's quadruple in quantity. So what I've got here, and our technician has very kindly gone to work with a saw. I have a set of weighing scales, which I shouldn't touch as I'm turning them on. And what I have here is I have a piece of wood, and then I've got a piece of perspex. And this perspex is both double in bulk, it is twice the volume, and as we found out from the data booklet, it's double in density also. So Newton says, in that case, if it is double in both volume and in density, then the quantity of matter is quadruple. It should be 4 times. So if we measure the wood is about 44 grams. If we measure the perspex, it's 174 grams. Near enough. It shows that Newton was right, that the quantity of matter has actually gone up by a factor of 4 because both the density and the bulk has doubled. And so that helps us. He talks about that this is also true for air and powders and other things that can be thought of, but directly linking it all the time back to these two things, density and the bulk measured conjunctly. And he says, I mean hereafter, everywhere, under the name of body or mass. Mass itself is the quantity of matter. And then he makes the point of he's not going to talk about weight just yet. He says that he shall hereafter. Now, of course, this is further on in Newton's Principia. So there we have it. The very first definition on the very first page of Principia can be understood, and it can be demonstrated with a piece of wood and a piece of perspex.